Hi guys, hope all doing good. In this session, we will discuss about motion analysis of follower, especially the simple harmonic case from CAM follower chapter. So to enable you to understand it in a better way, let us memorize few basic concepts of. So this is a CAM follower setups given in two positions. So this is the follower in guides. This is CAM mounted on a shaft, which is again mounted on bearings. So this is, for example, this is a given profile of CAM. Then this rises lowest point. Say if it is this one is the lowest point of the follower. Sorry. Then it has if it is rotating in anti-clockwise direction or counterclockwise direction, then CAM has to rotate through certain angle so that it is evident from the picture that as it rotates in counterclockwise, this CAM rises above upper side. So it rises. So as it rises up to this point, it will rise. This point is nothing but it is inferred in the position 2 up to this point. This is again circular where this part comes under dwell. So we know generally used CAMs are dwell, rise, dwell, return, dwell. So if that is the case, where generally dwell occurs when a circular profile occurs. This portion is circular, so as long as follower contact point is in this zone, it will be a dwell. Again, this is a circular portion with respect to certain center with some radius. So this again will be a dwell portion, but remaining portion continuously changes its center of radius. So curvature is continuously changing, and this part and for this part. So it automatically there will be some rising or falling down. So if this is the start of rising, that means it is at the lowest point of follower. Now as it rotates up to this point, it will rise. So this is the circular part. This angle can be phi A, which is angle of ascent. So this is the angle through which this CAM has to be rotated to ensure that follower shifts from its lowest point to the highest point. So this is the final position at the highest point. So highest point of follower, the highest position of follower. So this is the difference. This is the height h through which follower rises, and from here to here again it is dwell. When it is rotated further from here to this point, from this point to this point, it will again start falling, and again it will fall from highest point to lowest point. That is, again it will from h to 0. So that is the return stage. And so phi A is angle of ascent, and this part again it will be mentioned as phi D, which is angle of descent. It represents falling of the follower from to its lowest point from highest point. So this both in general can be specified by angle phi, which is angle of CAM through which, or angle of CAM, or angle through which a CAM needs to be rotated to rise or to have maximum displacement of follower. It may be rise or fall from lowest point to highest point or highest point to lowest point. Maximum displacement of follower. Now when we are clear with this, there are few more data I need to convey you. So if we consider small s as instantaneous follower displacement, h small h as maximum follower displacement, v as velocity of the follower, f as acceleration of the follower, theta as instantaneous cam rotation angle, and phi, which I already discussed, angle through which a cam needs to be rotated to have a maximum displacement of the follower. So beta is the angle on the harmonic circle. What is harmonic circle? I will tell you. Now from this you have to understand, we have already discussed maximum follower displacement h occurs when a cam is rotated through an angle of phi. It may be phi a, angle of ascent, or phi d, angle of descent. And when cam is rotated through certain angle theta, an instantaneous displacement s occurs. So these two things also have to be considered. Now from this, how to draw and how to analyze simple harmonic motion of follower, we will discuss. When we plot h, the maximum displacement against maximum cam angle, we will get it as say this is the maximum cam angle h equivalent to this h, and we already know that we need to study only 360 degree, that is one complete revolution of cam profile, that will be cyclic every time. So from 0 to 360 degree, if 0 to some 360 degree is there, and this is theta line, so maximum h is obtained in that 360 degrees. I have already discussed, this is the cam profile. So this total is 360 degree. Phi occurs from this part to this part, which means this is phi a or phi, and another part is this part to this part, which is phi d. Anyway, phi, but general term phi. So this can be regarded as phi. Now we have to divide this. This is the phi plotted against h, maximum displacement of follower, maximum cam angle, or cam angle through which cam is rotated, so that we get maximum follower displacement. Now equivalent to this we will draw at 0 degrees, or starting of the cam rise or cam follow. So equivalent to this means same as h, right? When we draw with this as diameter, so with this as diameter, we have to draw a semicircle. So this semicircle is nothing but the harmonic semicircle, which I have already discussed, termed it earlier, coined this term earlier. Okay, now we will divide this harmonic circle and this phi axis into n parts. Divide this into n parts, equal parts, n equal parts, where n is even. So let us divide into 6 parts. So it will be 1, 2, 3, 4, 5. So which can be divided as 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 parts. Similarly, we will divide the harmonic circle as well into 6 parts. This will be the midpoint of this total semicircle. Now 1, 2, 1, 2. So total 1, 2, 3, 4, 5, 6. So 6 equal parts. We will divide this arc into 6 equal parts. Now when we draw vertical lines through these parts, segments, we will get so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, now this is 0, this is 1, this is 2, this is 3, 4, 5, 6. Now join this part. Now from center of or midpoint of this line, like a diameter of this semicircle, we join the segments wherever we are dividing the semicircle. Now from here you draw parallel lines to 5 from these intercepts. These are the arc intercepts that we have divided into equal parts. From these intercept points we will draw lines parallel to the phi line, that is cam angle displacement line. Now this will 1 up to 1, this 2 up to 2, 3 up to 3, 4 up to 4, 5 up to 5, 6 and up to 6. So wherever this intercept on arc is intersecting this line on 1 on the phi line, that will be the first point. 2 on 2 second point, 3 on 3 third point, 4 on 4 fourth point, 5th and 6th. Now join this by smooth curve. So this will become a simple harmonic curve for one part. Similarly, this is rise part. When it comes to fall, it will be symmetrical to this part. So this is how we have to construct the profile or displacement diagram of the follower. So this is displacement diagram of the follower for the rise part, only for rise part. Now this is phi. So for example, this is theta. So this is theta. Means cam has been rotated. In this phi we have rotated from 0 to only this part theta. Then in simple harmonic, to get that intercept we have to move up to this point. So from 0 degree part to 2 we have to turn through beta. So this is nothing but the harmonic angle that we have discussed earlier. Now what is this value? This is total is h. So this part will be h by 2. In that this part will be, since this is beta angle, so this is not, this intercept part is nothing but this part. Now this is given by, this is radius of the harmonic circle. Let's say it is, radius is nothing but this half of this total height, that is h by 2. So h by 2 into cos beta will give this part, this intercept. So when you want this height or displacement, yes, of the follower, when it is rotated from 0 to 2, the height is this part, nothing but this part. This is the displacement s. When you want s, you have to subtract this part from the total half. So s equal to h by 2 minus h by 2 cos beta. Now further modifying it, we can write it as h by 2 of 1 minus cos beta. So furthermore modifying it, we know when in simple harmonic case, a circle, when it is angle is pi, then on cam angle we get phi. So or we can in reverse also we can write, when it is phi, then we will get angle pi. Now when we are rotating it beta, it is theta. That means when we are rotating cam to theta, then we get beta angle on cam harmonic circle. Implies beta can be written as theta into pi by phi. So wherever beta is there, we can replace with this part. Now implies displacement curve will become S equal to h by 2 into 1 minus cos of pi by phi into theta. So this is the displacement curve of follower. Now further proceeding, this is equation number 1. Now if cam angular velocity is omega, then omega can be given by theta by t, certain instantaneous time in that instantaneous cam displacement, angular displacement, implies theta equal to omega into t. Now instead of omega, when we substitute, instead of theta, when we substitute omega t, we will get it as S equal to h by 2 into 1 minus cos of pi by phi into omega t. Okay. Now this is the final displacement equation for follower in terms of time t. It is in terms of cam angle theta. So this is equation number 2. Now to find velocity and acceleration, we know we have to differentiate displacement equations. So when you differentiate s with respect to t once, that means velocity we will get ds by dt. From above we will get h by 2 into sine of pi by phi omega t into pi omega by phi. So this is what we will get. So maximum possible value, this is a constant, this part is a constant, so only variable is this is sine of this with respect to time t. So for velocity can be maximum, then this total part is sine value is maximum. So when sine value is maximum, we will get Vmax. But what is the maximum value of sine? It is 1. So when sine is 1, what we will get? H into omega into pi divided by 2 phi. Okay, so this is the Vmax, and where does it occur? When pi by phi into omega t equal to pi by 2, 90 degrees, which implies omega t is nothing but theta equal to phi by 2. So at theta equal to phi by 2, we get maximum velocity h omega pi by 2 phi. Now further differentiating it for acceleration, we got velocity equation v equal to h by 2 into sine of pi omega t divided by phi into pi omega by phi. Right. Now dv by dt will give us the acceleration f, which will be given by h by 2 into pi omega of phi. This was the constant part. Now this is the variable part. So again we will get pi omega by phi into cos of pi omega t by phi. Now this will again, this is the acceleration, so which can be modified and written as h by 2 into pi omega by phi whole square cos of pi omega t into phi. So if this is equation number 3, this is equation number 4. So where can we get acceleration maximum? Where when this is a constant, only this is variable, acceleration can be maximum when cos value is 1, and where is cos value 1, pi omega t by phi equal to 0 degrees or pi degrees or n pi, where n is an integer. Now if it is 0 degrees, omega t is nothing but theta, so theta equal to 0 degrees. Means at the start of motion or at the start of rise, we will get maximum acceleration. So F max, what is the F max? Is h by 2 into pi omega by phi whole square. So this is the F max we get. And at theta equal to 0 or omega t equal to 0. Now when we want to draw displacement, velocity and everything all in one diagram. So first one we will proceed with displacement at first part, next velocity from that, next acceleration from that, next jerk. So jerk is again, you don't confuse, jerk is nothing but rate of change of acceleration with respect to time. So that is jerk. So when jerk is high, generally it happens at high speeds. So when jerk occurs, we will get noise and vibrations due to high inertial forces, and it will lead to early failure of the cam follower system. So we need to avoid jerks as far as possible. So coming to the simple harmonic motion total analysis in one step. First we will have displacement curve. So generally I have already told we will generally use dual rise, dual return, dual type of cam followers, which are generally symmetric with respect to rise and with respect to fall. So the first one is the displacement S curve. So it is 0 degree, it is 360 degree for total one rotation of the cam. Now say rise first up to 20 degree it is dual, and again at last 340 degree to 60 degrees again dual. In between 190 degrees there, 160 degrees there, 180 degrees there, and 270 degrees there. Now 160, sorry, it is 200 degree. Now rise starts from 20 degree and falls at 340 degree. When you project these lines all throughout vertically, now this is a displacement curve. When you come to displacement curve, it is simple. In simple harmonic motion, first it is dual part. So we will notify del for dual part and phi here for angle of ascent and phi d as angle of descent. If that is the case, this part it will be ascent phi a. If it is dual del, it is also dual del. Again it is phi d, and again it is del dual part. Now at 20 degree it will start harmonic. At midpoint 5 by 2 it will reach maximum velocity part, and at 160 degree it will be maximum height h. So it will be something like this. At this part it will dwell up to 200 degrees of cam. Then again it will start fall up to 5 by 2. It will be again maximum velocity case and downward trend. So this will be a displacement curve we get for simple harmonic. Now when we projecting that for velocity, on velocity, for velocities, since there is no displacement 0 to 20, it is no displacement. Okay, and from 20 degree to 160 degree, it is rise part, and rise part we have seen it is a function of sine. So sine at starting it will be 0, at ending it will be 0, at midpoint 5 by 2. It is 5 here, 5 by 2 is 90 degree for 20 to 160 degree system. So at this point velocity will be maximum. It will be sine curve, something like sinusoidal curve. Okay, again it is well part, there is no displacement, so the velocity is 0. Now here this will be a fall, so velocity will be in the negative direction. Magnitude wise it is maximum at 270 degree, midpoint of the fall part 5d by 2, start and ending it is again 0. Now based on velocity, when we draw acceleration curve, now from 0 to 20 degrees there is no displacement, so nothing will be there. Now from here acceleration curve is a cos function, it will be maximum at starting and ending. Now one thing we have to observe here, at midpoint we already the acceleration will be 0. Because midpoint means if this is the total degree, this is 5 by 2 case, where for acceleration it is a cos function we will get in the brackets. When we substitute this angle we will get 5 by 2. So cos 5 by 2 will be a 0 thing. So cos, again this will be maximum on negative side. So in phi a, two maximum accelerations we will get, one on positive side, another on negative side, that is deceleration. So this curve will become like this. Now again here note it complete dual part, where no displacement, no velocity, and hence no acceleration as well. So acceleration is constant in this part, the velocity is constant, so acceleration 0. Now again in this part velocity will increase in negative side, so acceleration and velocity will reduce. So change is towards negative it is positive, and towards negative it is negative, means decreasing. So again acceleration here 0 at midpoint 5d by 2 for acceleration. So regarding is a cosine curve, starting at 0 degrees it is 90, at ending it is 1. Starting and ending it is maximum values of acceleration, but only sign changes, positive side and negative side and positive side. 0 at the midpoint it is 90 degrees from starting, from here to here 90 degrees, I mean 5 by 2. So cos of pi omega t divided by phi, what we got, this part will become pi by 2 for this point and this point, the hence cos is 0, hence acceleration is 0 as these 2 points. Now further when we draw jerk diagram for this, the starting point there is nothing, this is jerk. Starting there is nothing, but here abruptly acceleration changes from 0 to certain value. So abrupt change means t tends to 0 in the denominator, some acceleration finite value divided by t, change in acceleration by t. T tends to 0 means the jerk value tends to infinity. So it tends to infinity. Now just before this it was infinity, and after this it comes from infinity. Jerk will again be a sinusoidal curve. Differentiation of acceleration is nothing with jerk. So acceleration is in cosine case, because acceleration we know some constant into cos of something. So when we try to find jerk, we will differentiate acceleration, which will again in terms of sine. So it will be sinusoidal curve, but it will be in negative side. So up to here there is no part, sorry. And at this point again, abrupt change in acceleration. So it is acceleration is actually increasing in its value from negative to 0. So it is going towards infinity and come back from infinity to 0 value at this point. Again here acceleration is going towards it is negative change, so towards negative infinity, and again come back to from infinity to this value. So it will be again sinusoidally given like this, and again here it will abrupt change is there, so again it reaches infinity, and again come back to infinity, and for this part it will begin 0 jump. So this way we will get the total motion analysis for simple harmonic motion of follower.